A study of the number of business lunches that executives claim as expenses per month gives the following results. 60 bank executives average 8.4 such deductions with a standard deviation of 1.8, while 50 insurance executives average 9.6 deductions with a standard deviation of 2.1. Test the claim that bank executives have fewer deductions per month on average than insurance executives using a level of significance of 0.005. So there's a lot of numbers thrown out here. It's probably best to organize everything into a table. So let's do that first. Okay, so what I've done is just kind of parsed out the data and put it into a nice table here. I have group 1, which basically I'm labeling group 1 as my bank executives. And group 2 I'm labeling as the insurance executives. Now, it doesn't matter which one I choose for group 1 and which one I choose for group 2, as long as I'm consistent with that throughout the problem. So my claim here, the thing that I'm testing, is that bank executives have fewer deductions per month on average than insurance executives. So I'm going to test the claim that mu1 is less than mu2. So I need to fill in my null hypothesis, my alternative hypothesis. So let's put that in. So here is my alternative hypothesis, since it has a less than symbol in it and it's not an equal sign. The only one that ever goes in the null is the equals. So this is my original claim. So the null is going to be that mu1 is equal to mu2. Whoops. There we go. Now, the next thing I need to do is come up with a p-value. And again, that's where the calculator comes in. So under my tests menu, I need to decide on which one I'm going to use. Now I have two samples that I'm comparing. So it's either going to be 2 sample Z or 2 sample T, because we didn't do a 2 sample proportions test. In this case, it's going to be 2 sample T. All right, so my stats that I'm given, the mean of group 1 is 8.4. Standard deviation of group 1 is 1.8. And the sample size of group 1 is 60. The mean of group 2 is 9.6. The standard deviation of group 2 is 2.1 and 50 for the sample size. Now the symbol in the alternative is a less than, so I'm going to select here. Of course, I want no as my answer to the pooled estimate, or pooled number of degrees of freedom or something. And calculate. Okay, so my p-value, if you notice here, it looks like 9.81, 5, 6, and then at the end you have the e minus 4. Now don't forget that e minus 4 is important, because what this means is, 9.8156 basically times 10 raised to the negative 4th power, which would be 0.000988156. So when I get my p-value, just make sure you round properly. And I always round decimal percentages and probabilities to 4 decimals. So if I go to 4 decimal places here, that means the 8's going to round the 9 up. So my p-value is in fact going to be 0.0010. Now, as a percentage, that's still pretty small. It's 0.1%. And I'm comparing that to my alpha level, which is the alpha level is the same thing as your level of significance. And that's going to be 0.5% if you change that into a percentage from a decimal. But 0.1 is less than 0.5. So my decision here is to reject the null hypothesis. So now it's just a matter of filling in this last sentence. So the first blank is either is or is not. Since in this case I rejected the null hypothesis, I'm going to put is. And the second blank is either going to be support or reject. And since my original claim is in the alternative hypothesis, I am trying to support it. So in this case, there is enough evidence to support the claim that bank executives have on average fewer deductions per month than insurance executives.